Okay, so let us start with the session. In yesterday's session, I had explained you the input-output instructions. Okay, and I told you that I'll be discussing the IEN part in the next session. So we had completed with memory reference instructions, register reference instructions, and input-output instructions. Okay, we had discussed each of the instruction in detail. But in input-output instruction, important concept to be understood is about interrupts. So first of all, when we talk about interrupt, what is an interrupt? So today what we'll be doing is we'll be studying, yes, we'll be studying interrupt. Okay, and the interrupt cycle. So when we talk about interrupt, interrupt is nothing but an operation which takes place when some input or output operation occurs. See, input and output operations are asynchronous. We do not know, they are not fixed. We do not know the time at which they would occur. Okay, I don't know, the computer will not be knowing that when the user will be giving input to the computer. Fine, and hence we will be considering these operations to be interrupt. So what happens is during the normal execution of a program, interrupt may occur, and when an interrupt occurs, we will have to change the control of execution of our program. Normal instructions are going on. We have studied all the normal instructions. It can be memory reference instruction. It can be any register reference instruction. But as soon as an interrupt occurs, what we will have to do? We will have to change the normal flow of our execution. Why? Because it has to be given priority, right? Because as soon as some input has been received from the user, okay, we need to inform the computer that for a while stop the normal execution and execute this interrupt part. Okay, so that interrupt is generated. So now let us see the this interrupt cycle. How to identify when an interrupt occurs and what steps are to be taken when this type of when any of the input output operation occurs, when such an interrupt occurs during our normal execution. Okay, so for this, let us see how it works now. So for this, we have a flip-flop known as R flip-flop. Okay, this R flip-flop will decide whether it is a normal instruction or it is an interrupt. Okay, if the value of R is set to 0, if the value of R is 0, it means it is our normal instruction cycle. Okay, normal instruction cycle. So it will start with the fetch and decode phase. It will fetch and decode the instruction, and then it would execute the instruction. This is the instruction cycle which we studied earlier. Okay, so if my value of R is 0, it is treated to be a normal instruction cycle. So it would go and fetch, it would go to fetch and decode phase of the instruction, and then it would execute the instruction. Now, what if during the fetch and decode instruction phase, your interrupt enable flag is set to 1? Okay, during this, what happened? In the yesterday's session, we have studied there are two flags. There is a flag called interrupt enable. Okay, it can be set to on or it can be set to off. Whenever some input interrupt occurs, this IEN would be set to on. Okay, so during this fetch and decode instruction, when this interrupt enable is on, we need to check what we will be checking. See, if it's 0, if this IEN is 0, it means nothing. You are executing your normal instructions. Okay, if it is 0. But what if this IEN is set to 1? In this case, there are chances that some interrupt has occurred. Okay, now, what do we need to check? We do not know. We only know that an interrupt has occurred. So which flags will we check to identify which type of interrupt has occurred? IEN is also some sort of flip-flop. Yes, Dhruvin, it is also a flip-flop. Yesterday I told you that it is a flip-flop. It has two values, either 0 or 1. Okay, and we had seen some instructions. We had seen this instructions that when interrupt on, instruction occurs, what happens is IEN flag is set to 1. Similarly, when interrupt off, it means IEN is set to 0. This indicates when IEN is 1, it means interrupt is on, that is interrupt has occurred. And when IEN is 0, interrupt enable is off. Okay. So, yeah. So when some interrupt has occurred, now we need to identify which interrupt has occurred, whether it is an input interrupt or an output interrupt. Okay. So can you tell me which flags are checked to identify whether it is an input? Yes, FGI and FGO. So suppose I check FGI first. Okay. So if my FGI is 0, if FGI is not on, it means what? I'll have to check FGO. Okay, if FGI is not set, it means this FGO flag must be on. So if this flag is on, it means an output interrupt has occurred. Okay, so if this FGO, that is output flag, is set to 1, what we need to do is we need to set our R flip-flop to 1. We are not doing it, okay, the computer does this. So whenever this FGO flag is set to 1, the value of R is set to 1. It means, what did we, when we started off the cycle, what did I tell you? That R is a flip-flop which helps us to identify whether it is a normal instruction or a interrupt. Okay, so when FGI is 0, FGO would be 1. If FGO is 1, R is set to 1. Similarly, if FGI is 1, in that case also R is set to 1. Okay, here if FGI is 1, in this case also R is set to 1. So when can I say that an interrupt has occurred? When IEN is 1 and either FGO or FGI is 1. Okay, so if this is fulfilled, it means we can say that an interrupt has occurred. And when an interrupt has occurred, this R flag is set to 1. Okay, ये हम बाद में देखते हैं. Yeah, if FGO is 0, again nothing. Fine. Chalo, now let us see what would happen when R is set to 1, the other branch of our flowchart. This was what? When R is 0, this is my normal instruction cycle. Again, during my normal instruction cycle, if during the fetch and decode phase or any other phase, an interrupt has occurred, what to do? Okay, so at this point of time, our R would be set to 1. Now, when R is not 0 and R is 1, it means an interrupt has occurred. Now, this interrupts working is similar to our branch and save return address instruction. Okay, you need to, we discussed in the beginning that whenever some interrupt occurs, we need to change the flow. We need to change the control of execution of our program. Okay, it means we need to branch to some other address and execute that input output operation first, right? So here it is same as our branch and save return address operation, but the only difference over here is in branch and save return address, what we were doing, we were branching to a particular location which was mentioned in AR. Okay, here it is fixed that what we will do is our return address will be branching to location 0 of memory. For any interrupt, where would we branch to? We would be branching to location 0 and then execute the input output program over there. Okay, instruction over there. So now, if my value of R is 1, what we will do, we will store our return address in location 0. Recall the branch and save return address. In that, what we were doing, we were storing the value of PC, that is the next instruction, that is return address, in M of AR. Okay, but here what we will do is we will be storing that return address at location 0. Fine. Now, After this, what we will do, we will branch to that location. हम AR+1 पे transfer branch करते थे ना. I'll show you that branch and save return address instruction. In that, what we'll be doing? This one. Okay. Here we were storing. आ गई अपनी instruction. We were storing this at M of 135, and then our execution starts from 135 plus 1, that is 136. Okay, this 136 would have our subroutine. So here, now that we are storing our return address at location 0, where will my subroutine start from? It would be starting from 1. Okay, so what we will do over here, we will branch to location 1. And we will store 1 in our program counter. Okay, when this program, when 1 is stored in the program counter, it would, whatever is at 1, जैसे यहाँ पे, here we are storing AR in PC, so my execution starts from here, from location 136. Okay, and now here, so here this part would be executed. Fine. Similarly, here we are branching to location 1 and storing 1 to PC. Once this, so after this part gets executed, okay, after this interrupt gets executed, what we need to do? Interrupt का काम खत्म हो गया. So now we will set the IEN flag to 0, interrupt off. Okay, and again we'll set R also to 0, interrupt over. When R is 1, there is an interrupt. But ये interrupt पूरा execute हो गया, whatever was in by either input or output operation, whatever took place, got executed. So now we will set back this IEN to 0. Am I audible? Okay, so we will set this IEN flag is set to 0, R flag is set to 0, and after all these things, it will go back to our instruction cycle. Over here, it will go back and check the value of R. Depending upon R, it will move to the normal instruction cycle or the interrupt cycle. This is your interrupt cycle. Understood? All of you? How does this interrupt cycle work? I'll show a neat diagram. Okay, so this is the flowchart of the interrupt cycle. This R is a flip-flop which decides whether it is a normal instruction cycle or an interrupt cycle. If it's a normal instruction cycle, the value of R is 0 and it will go to the fetch and decode phase, and the execution, it would execute instruction. But during this phase, if some interrupt occurs, what will it do? It would check the value of FGI or FGO. If either of them is 1, the value of R is set to 1, indicating that an interrupt has occurred. And when an interrupt has occurred, when it goes back to the instruction cycle, if you look at this figure, after setting R to 1, it again goes back over here. यहाँ पे. Okay, and then it again checks. If the value of R is 1, it would go back to this branch of the flowchart where interrupt cycle is explained. And in this interrupt cycle, the interrupt that is executed works same as your BSA instruction, that is branch and save return address. The only difference over here is instead of moving to a particular location, we are here moving in interrupt cycle, we are moving to a fixed location, which is location 0. Okay, so now what we do is in M of 0, we save the program counter. Okay, after saving the return address in M of 0, we'll be moving to location 1. This PC is set to 1. Here the whatever is the interrupt instruction is executed, and then after completion of this interrupt flag, that is IEN flag, is set to 0. R is again set to 0. so that now now we can move ahead with execution of our normal instruction cycle. Okay, so now from this flow chart, let us see the register transfer statements for interrupt cycle. That was our flow chart. Okay, so now let us see the register transfer statements for interrupt cycle. Chalo. When should I set the value of R to 1? What would be the condition for setting the value of R to 1? Who would tell me? See, this T0, T1, T2 all should be 0. Okay, it is not occurring at that particular timing signal. Okay, as soon as this interrupt has occurred, all this would be 0. Fine, it is not occurring at timing signal T0, T1 or T2. So all these are 0. Then interrupt flag is on, IEN is 1. Okay, look at our flow chart. IEN should be 1. And either of FGI or FGO is 1. In our control function, do you remember this plus indicates what? OR operation. Okay, and if it is on the right hand side, this is your OR. In control function, when I want to indicate OR, I'll be using plus symbol. Okay, so in this condition, we will have to set our R. We will need the R is set to 1. Okay, so if it is T0 dash, T1 dash or T2 dash, IEN is 1, either FGI or FGO is 1, then the interrupt has occurred and hence R is set to 1. Okay. Any doubt in this? Okay, so now this is the left hand side of our flowchart. When to set R to 1. Okay, now when an interrupt has occurred, that is, if the value of R is 1, what steps are carried out? In address register 0, in address register AR, 0 is stored. Okay, then at timing signals T0. See, now again when interrupt cycle starts working, this interrupt cycle starts working, it would start from timing signal T0. Okay. Now let us see the steps involved when interrupt cycle occurs. Okay, when interrupt occurs. So first of all, we know that we are moving to a specific location 0. Okay, so AR is set to 0 and in temporary register what we will do is we will store the value of PC. At RT1, M of AR, in M of AR, we will be storing the value of this TR. Okay, अभी हमने कहा कि PC की value we will be storing at location M of 0. That we had directly written. Actually, what we are doing is we are doing nothing, but we are doing this thing only. At location 0, store the value of PC. That is, you are storing the return address. Okay, now, so here what we are doing is at M of AR is, this is our return address. This return address we are storing in M of 0, and then in PC, what we will do is we'll store 0. Okay, because we want to jump to that particular location. At RT2, what would happen? We know that our subroutine starts from 0 plus 1 location. So what we will do is we'll increment the value of PC by 1. Okay, ये हमने जो ऊपर इसमें लिखा PC को 1 किया. This is what? This is nothing but we are moving to that particular location of our subroutine. This interrupt is nothing but a small function to be executed whenever some external input or output event occurs. Okay, so what would happen? We will be moving to this particular location, executing our interrupt, and then we'll be setting our IEN to 0, R to 0, and sequence counter back to 0. Okay, this is an instruction that executed. So after this instruction gets executed, again we'll set the sequence counter also to 0 so that the next instruction starts from timing signal 0. पता चला what did we do at RT0? We stored 0 in AR because हम सीधा ऐसा नहीं लिखेंगे ना m of 0 equals to this. We will be specifying it in our how memory cannot be accessed directly. It access its value from address register. So what did we do? We stored 0 to AR and I will have to store this value also somewhere because मुझे PC के अंदर कुछ डालना है तो PC की वैल्यू कहीं स्टोर करके रखेंगे तो उसको कहाँ स्टोर करके रखा in temporary register. Okay, now this temporary register's value we are transferring it to M of AR. That is, in M of AR we'll be transferring the next location. After that, setting PC to 1, moving to the next going to this particular location, that is first location for executing the interrupt. Once the interrupt gets executed, we will set यानी executed यानी इस location पे हम पहुंच गए, ये वाली instructions execute होने लगेगी, but इसी time पे हम क्या कर देंगे, our interrupt task is done. So we will set this IEN to 0, our R value which is helping us to identify whether it is an interrupt or a normal instruction to 0, and SC to 0. Okay, so this is your interrupt cycle. Here it is, if you look at your book here, the same example जैसे हमने branch and save return address वाला देखा था उसी तरह से यहाँ पे also they have explained it through an example. This is your instruction that is to be executed. Okay, this is your main program. Suppose right now you're at current instruction 255, an interrupt has occurred. So what would happen? This value of when this interrupt occurs, okay, what would happen at 0th location? Return address. What is the return address? We need to return back to the next instruction, that is PC plus 1. So this return address is stored at memory location 0. Okay. In program counter, we set 1 so that whatever instruction is there, interrupt wali instruction at this particular location, this is your input output program, the interrupt that which has occurred. Okay. So PC is set to 1. वो इंस्ट्रक्शन कहाँ पे होगी at location 1 and hence we are setting the value of PC to 1. So now what would happen? It would go to location 110. Whatever task is to be carried out in response to that interrupt is executed. और जैसे उसमें था branch and save return address में indirect addressing कहाँ पे it is redirecting it to at location 0. At location 0 it will go over here and as it is 1 over here, as it is an indirect address over here, आपका 256 location memory में यहाँ पे 0th location पे लिखा है. So where will your program execution jump? It would jump to 256th instruction and your normal instructions would get executed. Did you understand what happened? You are currently, this is your before interrupt. You are currently at this location. Interrupt occurred. When this interrupt occurred, what happened? In your PC, you will first of all store the return address that is abhi current PC plus 1 at location 0. Okay? यानी 256 location 0 पे store हो गया. We are setting the value of PC to 1 so that I can execute the instruction which is kept over here. Fine. This instruction would be executed. और इसमें क्या है? This is nothing but we are changing the control of our execution. It means we will jump to the location of the function. Okay, of our subroutine. तो वो कौन से location पे है? 1120 पे. So we came over here. After completion of every subroutine or function, there is a return statement. This is your return statement. Where is it redirecting your execution to? It is redirecting your execution to location 0. Okay, and as it is an indirect addressing mode, at location 0 is specified the instruction which is to be executed next. Okay, so this instruction is at location 256. तो ये 256 वाला part से अब वापस execution start हो जाएगा. Did you understand? all of you. So this was all about interrupt cycle. Okay, we started off with what is an interrupt. Then we saw the interrupt cycle. Depending upon the value of R, if R is 0, normal instruction cycle gets executed. If R is 1, your interrupt cycle gets executed. After that, we saw the register transfer language for representing an interrupt cycle. First register transfer language which we saw was, it's given over here. Yes, first register transfer language specifies when to set the value of R to 1. It is set when T0, T1, T2 all are 0, IEN is 1, and either FGI or FGO is 1. Okay, at that particular time, the value of R is 1. After that, when R is 1, that is when interrupt has occurred, that is confirmed, we will move away from our normal execution. We will set this AR to 0 and store PC into temporary register. This at location M of AR, whatever was in PC. Okay, next instruction अपने कहाँ गई? Next instruction would be अभी PC अगर ये है, this instruction is being executed, my program counter is pointing to 256 location. So what we are doing is we are storing PC to memory address 0. ठीक है, ये PC की वैल्यू हमने TR में ली और फिर उसको हम कहाँ स्टोर कर रहे हैं? एट मेमोरी लोकेशन 0. एंड नाउ वी आर मूविंग PC to 0 सो दैट अब मुझे कहाँ एग्जीक्यूशन करने जाना है? आई नीड टू गो बैक टू 0th लोकेशन. ओके, मुझे PC को कहाँ ले जाना है? आई हैव टू गो टू दिस पर्टिकुलर लोकेशन. फाइन, 0th पे हमने एड्रेस स्टोर किया और फिर PC इक्वल टू 1 से हमारा एग्जीक्यूशन स्टार्ट होगा. सो व्हाट वी आर डूइंग इज वी आर setting PC to 0 and then execution will start from PC plus 1. That would be my next instruction to be executed. That is your input output program. Okay, so here in 1, whatever instruction is executed, that particular subroutine would be executed, and this return statement would specify us to go back to location 256 for our next instruction. Okay, ये 256 पे हमारी next instruction होगी. This is indirect addressing. तो 0th location, this is your 0, this is address is specified 0. तो वो 0 वाली execution instruction execute नहीं करेगा, but 0 पे जो address आपने specify किया है, उस address वाली location को it would execute. Why? Because as it is an indirect addressing mode. Did you understand, all of you? Okay, so this completes your interrupt cycle. Okay, I'll not be moving ahead today. In the next class, we'll be seeing the designing portion. Okay, the entire अभी तक हमने जितना पढ़ा उसका पूरा summarization is carried out in this complete computer description. Fine, we studied different instructions, we studied the instruction cycle, we studied the common bus, and we studied the interrupt cycle. So now we'll be integrating all these things together for the entire designing process. Okay. चलो, so if you have any doubts in today's session, interrupt cycle, you can ask me. मैंने 2 बार ये पूरा आपको रिवाइज करके बता दिया. Still, if you have not understood this interrupt part, you can ask me.